Hi friends, welcome to my presentation. In front of you this is Vaishnavi Junior M.P.C from TTWREIS CY Girls Kalakurti. Before going to our session will be started with some examples. In our day-to-day life, we observe lot of things around us. Apart from that, what you observe on this slide? The cradle, and second one is pendulum clock. What is the relation between cradle and pendulum clock? The pendulum clock is known as the clock which is consisted with pendulum. It is known as the pendulum clock. The cradle at rest position, when we apply some amount of force on it, it oscillates. Even pendulum also in oscillate. Both are relations, both are in oscillate. Beside this, suppose the object which I pulls from my hand, it again comes to its original position. Why it's happening? We already know it is because due to gravity. Due to attraction of gravity, it again comes to its original position. This all about we learned in our previous classes. Apart from this example, how to calculate acceleration due to gravity. It's possible to calculate acceleration due to gravity. We already know our Earth gravity 9.8 meter per second square. By using this, we understand that we are able to calculate acceleration due to gravity. Then how? How to calculate acceleration due to gravity, or what is oscillate of the body? All this example I give clarity in today our session. Our session is today going on the topic oscillation. The topic oscillations today I am going to deal you. Today's our objectives are motion, periodic motion, SHM, terms related to SHM, simple pendulum and the derivation of time period, and we calculate the L by T square value by practically. First one, motion. Suppose you observe the body which now the right side of my hand, after certain time it travel to left side of my hand. Here the body change its position with fixed point and fixed time. It is known as the motion. Periodic motion. We already know the motion means the body moves one place to another place. It's known as the motion. The periodic motion means the period. Period means regular interval of time. If the motion repeats in a regular interval of time, it's known as the periodic motion. Suppose uniform circular motion. It's the example of periodic motion. Even you observe on the slide the body which they are rotating around a center point. In a regular interval of time, here the motion will be occurs. Suppose the earth rotation around the sun. It is the periodic motion because here the earth rotates in a regular interval of time. Oscillatory motion, which I use the word oscillate in our examples. The periodic motion which the body moves to and fro from a fixed point. It's known as the oscillatory motion. Which you observe the examples, the cradle or even pendulum clocks, both are in oscillatory motion. The body moves to and fro from a fixed point. You observe on the slide, here the one bob which moved to and fro from a fixed point. From periodic motion and oscillatory motion, what is similarities or what is different between periodic motion and oscillatory motion? The periodic motion and oscillatory motion similarities both are in periodic motion, means both repeats in a regular interval of time, but periodic motion which the body moves in the circular path, a linear path or curvilinear path. But when it comes to oscillatory motion, here body particular move in to and fro from a fixed point. It is the difference between periodic motion and oscillatory motion. The main thing, note down you, here all oscillatory motion need not to be periodic motion, but all oscillatory motion is need to periodic motion, but all periodic motion need not to be oscillatory motion. Suppose some example, the earth rotation around the sun is a periodic motion, we already discussed, but it is not a oscillatory motion because it is moving in a circular path. When it comes to oscillatory conditions, the motion must be in a straight path. I hope you are understanding what is the difference between oscillatory motion and periodic motion. SHM, the simple harmonic motion. This simple harmonic motion is a special case of periodic motion. In our day-to-day life, we observe lot of motions around us. Circular motion, rectilinear motion, curvilinear motion we observe around us. By using path or by using direction, we consider certain motion as a circular or linear. Then, how we consider certain motion as a simple harmonic motion? By using some rules, some conditions, we able to consult the motion is a simple harmonic motion. The condition is, the first condition, to and fro motion from a fixed point. The body to and fro motion from a fixed point. The second condition is SHM must be in a straight path. The SHM must be in a straight path. And the third condition is acceleration of the particle is directly proportional to the displacement of the particle. Here we indicate minus sign. Here minus sign can't indicate for cancellation of the value or minus of the value. Here minus sign actually indicate the acceleration of the particle and the displacement both are in opposite direction. Where the proportional is removed, the A is equals to minus omega square x, omega square where constant term. I hope you are understanding how to consider certain motion as a simple harmonic motion. By using this rule, you able to consider certain motion as a simple harmonic motion. The terms related to SHM. First one is amplitude. The maximum displacement of the oscillatory particles on either sides from its mean position, it is known as the amplitude. Once observe on the slide, you look at a line, that is the amplitude. Even a midpoint, we call the mean position. The position of the object which net force act on it is 0, it is known as the mean position of the object. Even extreme position of the objects, the maximum distance from the mean position, it is known as the extreme position of the object. Time period. The time taken by oscillatory particles to complete one oscillation, it is known as the time period, where the time period indicated by capital T and the units of the time period seconds. Frequency. The number of oscillations per seconds is known as the frequency, where the frequency is a reciprocal of time period L by T. And the units of frequency seconds inverse are Hz. Angular frequency omega is equals to 2 pi by T. In the place of omega, we replace 2 pi by T. Next, calculation of time period of simple pendulum. By using this concept simple pendulum, we able to calculate acceleration due to gravity, which I am saying example how to calculate acceleration due to gravity. By using this concept, we able to calculate acceleration due to gravity. Not only on our Earth, we able to calculate acceleration due to gravity on any planet in our solar system. Suppose, observe on the slide the simple pendulum. The metallic bob is suspended with weightless string from resected points. the weight of the bob is always vertically downward. Because of the W, weight is equals to m into g, mass into gravity. Gravity is always vertically downward, that's why the weight of the bob is always vertically downward. The length of the pendulum. The distance between resected point to center of mass of the bob, the covered distance, which we usually call the length of the pendulum. Now, the bob at rest position, when we are applying the little bit force on it, it's displaced with angular displacement, and which the object moves to mean to extreme position, it's covered some distance and it form an arc. Usually, we say the arc X. Next, here also when the bob moves to mean to extreme position, here the make angle theta, the angular displacement. Angular displacement is known as the body which displaces with making angle is known as the angular displacement. Even the body moves to means to extreme position. Now also the weight of the bob is vertically downward because we know that weight is mg, the gravity is always vertically downward. The mg resolve to rectangular compounds. The first one is mg cos theta and mg sin theta. mg cos theta is balance the tension and the mg cos theta along the string. mg sin theta is perpendicular to mg cos theta, where mg cos theta is restoring force. Restoring force means the mg cos sin theta is always pulls the object in backward direction to replace in its original position. The mg cos theta and mg sin theta, where the angle between mg cos theta and mg is theta, because where we form the angle, the length of the pendulum and the mg both are parallel. Next, from this we taken an equation, that is force is equals to minus mg sin theta. Restoring force is equals to minus mg sin theta. Why we take here mg sin theta? We can't able to take mg cos theta, because the mg cos theta is perpendicular to distance, where the angle is 90 degrees. We know cos 90 value is 0. Then work done by cos theta is 0. Then we take here the mg sin theta, where we indicate here minus sign, where the bob goes in a straight path, the mg cos theta is always pulls in the opposite direction. That's why here we indicate minus sign. From this diagram, sin theta is equals to theta, because where the theta is formed very small. You have the doubt why the theta will be formed very small. Even theta forms large, what happens? Here compulsory theta forms very small, because to satisfy SHM rule, from simple harmonic motion, the path must be in a straight line. If when you apply large amount of force on the bob, it displaces the large and make angle theta is a very big, and it's totally collapse our concept. Then you can apply the little bit force which makes angle theta is very small. So, okay, we go to our equation. F is equals to minus g theta. In the place of sin theta, we replace theta, because small theta is equals to sin theta or sin theta is equals to theta. According to Newton's second law, explain how force is equals to mass into acceleration. From Newton's second law, explain how force is equals to mass into acceleration. In the place of force, you replace m into a. Both side mass values cancel, and the remaining terms a is equals to minus g theta. Theta, here theta means angle, where the angle is equals to arc length by radius of the circle. Arc length, the distance between mean to extreme position, which we assume that x value, that is the arc length. Next, the length of the pendulum becomes the radius of the circle. When we draw circle from rejected points, then the length of the pendulum becomes the radius of the circle. Okay, our equation, angle is equals to arc length by radius. Theta is equals to x by L. In the place of theta, you replace x by L. Our equation becomes A is equals to minus g x by L, where g and L are the constant terms. Then we directly again prove that SHM rule. Acceleration of the particle is directly proportional to the displacement of the particle, where minus sign indicates the acceleration and displacement both are in opposite direction. Hence, we prove that. Next, A is equals to minus g x by L, where from SHM rule, acceleration of the particle is minus omega square x. Minus omega square x is equals to minus g x by L, where negative values cancel and x cancel. The equation omega square is equals to g by L. Then omega is equals to under root of g by L. Omega, the omega value from angular frequency, which we discussed the relative terms of SHM, from that angular frequency omega is equals to 2 pi by t. Place of omega, you replace 2 pi by t is equals to under root of g by L, where t is equals to 2 pi under root of L by z. Our equation, it becomes from where 2 pi is equals to t under root of g by L. Next, the g by L comes to 2 pi under root of g by L. Then the 2 pi, when g by L goes to the numerator, then 2 pi under root of L by g. The time period of the pendulum t is equals to 2 pi under root of L by g. By using this time period, we able to calculate acceleration due to gravity. From this equation, you take the gravity value squaring on both sides, then t square is equals to 4 pi square L by g, where g is equals to 4 pi square L by t square. Our equation finally got. I hope you understanding clearly the derivation part of the time period. By using this derivation part of the time period, you are able to calculate acceleration due to gravity. Here, even you know the 4 pi square are the constant term, but L by t square are the variables. By using this formula, you are able to calculate acceleration due to gravity. But how to calculate L by t square value? Is by how the practically proving how to calculate acceleration due to gravity? Are the L by t square value, because we know 4 pi square value, but here L by t square is a variable. Then now we calculate the L by t square value by practically. I hope you understand clearly the derivation. Now I clearly explain you the step by step processing to calculate the L by t square value, where 4 and pi square are constant. Now going to calculate L by t square value. For the calculation of L by t square value, we want some operators. By using simple pendulum, we are calculate the L by t square values and some operators. How to calculate acceleration due to gravity? Mainly 4 pi square is a constant term, L by t square is the variable. Now the value calculation of L by t square by tabular format. First, which you observe in the table, L, length of the pendulum. Next, time taken for 20 oscillations. Here we take the 20 oscillations, even you take the 15 or 10, you are able to got but for our favorness we are take here 20 oscillations, T1, T2, while we take against T2 because to minimizing the error to comes the accurate value. Average the time taken for 20 oscillations, the time period is equals to small t by 20, where we discuss time periods taken for one oscillation. The time period is known as the time taken for one oscillations. For calculation of one oscillations, the actual time period is equals to t by 20. T square. From our equation, the actual value we got the t square value. G is equals to 4 pi square L by t square. We want t square value. Then you square the t value. Next, L by t square, length by time period squaring. Now I am releasing the operators which we use to calculate the system. I hope you confused about this. I clearly say how to calculate length and how to calculate the time period for 20 oscillations. Okay, you observe here, these are the operators which we use to calculate the L by t square. First, the L means known as the length of the pendulum. Okay, before going to that, I can explain the operators used to calculate the L by t square values. This is retard stand. This is rubber cock. The rubber cock which used to balance the weightless string. The weightless string here the thread. The thread is weightless. The weightless string is the thread, and that is the scale for measurement of the length of the pendulum. This stopwatch. This is stopwatch. This seconds watcher. And the stopwatch, the mechanism of the stopwatch is we observe two switches either sides of the stopwatch. The right side switch used to start the time and stop the time. The left side switch we usually use to restart our time. This is the mechanism of stopwatch. By using this scale, we calculate the length of this simple pendulum. This is metallic bob. Usually, here we take on the metallic bob. Even in place of metallic bob, you take any object, you able to calculate acceleration due to gravity is possible. First, now the bob is at rest position. We apply some amount of force on it. Then it displays and then it oscillate to and fro. Now bob is at rest position. We apply some amount of force, and by this we calculate time taken for 20 oscillations. By using this timer, we calculate time period, and by applying some force on this bob, this start the displays. Okay friends, shall we apply some amount of force on the bob? Shall we start? Are you ready? Okay, ready and start the countdown. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Stop the timer. Now you note down the time taken for first 20 oscillations. Usually I am take here length is 50 centimeters. Before our session I already calculated the length of the pendulum is 50 centimeters. The time taken for 20 oscillation is 29 seconds. Okay. For note down the time 1 is equals to 29 seconds. The length of the pendulum 50 centimeters. Now again we do the trial for the minimizing the error to comes the accuracy value. Shall we start? Start, stop and restart the time. Applying some amount of force on it. I applying. Start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Stop the watch. Again you note down the time taken, the second note down the time. Now also we got the 29 seconds. But sometimes we got the little bit error. But now we got the clarity 29 seconds. T1 29 seconds and T2 also 29 seconds. Next, to average these T1 and T2. Sum of all observation by the number of observation, we calculate the T. Then T1 plus T2 by 2, we got the T value. Then capital time period is equals to small t by 20. By small t by 20, we got the time period. Squaring the time period, you got the t square value. Then L by t square means length by t square value. For all is, before our session, I already do activity. I take the different measurements 40, 50, 60, 70, 80, 90 centimeters of the length, where the length is directly proportional to the time of the oscillation. Then when the length I increase, the time also increasing. Where I take the 60 various length of the simple pendulum before our session, now also we do, but it is taken the lot amount of time. These values are accuracy I got. Next, the total L by t square, I have the 6 values L by t square, sum of all observation by the number of observation, we got the actually average value is 24.75 centimeters per second square. Next, this value substitutes in our equation. G is equals to 4 into pi value 3.14 into 3.14 into we got value L by t square. Then we got the actually gravity value 976.10 centimeter per second square. This converted into meter. Then we got G is equals to 9.76 meter per second square, because 1 meter is equal to 100 centimeters. You got the actually value. By using this, you able to calculate acceleration due to gravity on any planet in our solar system. I lastly conclude that I hope you all are enjoying my class. Next time you try, you confirmly got accurate value of the gravity. Thank you to my special thanks to whole team T-shirt channel and our secretary sir, our RC sir, OSD sir, and the TTWREIS COI girls principal Alivelu madam garu, and my guide teachers Sridhar sir, Bhaskar sir and Umadevi madam garu. And thank you to my parents and thank you all my teachers to giving the wonderful opportunity. Thank you.